Okay, I think it's slowed down a little bit. Excellent. Well, welcome everybody. Today on this webinar, we are learning how to customize your Pitts21 bracket prescriptions. This is a powerful skill that gives doctors the ability to minimize wire bending without the high cost of custom brackets. So it's pretty cool. So if anybody here is offended by working smarter and saving money at the same time, you are in the completely wrong place. That is some other webinar. But hey, it's good to have you here. My name is Ryan Williams. I'm the Vice President of Sales for DIBS AI. We would like to recognize and thank OC Orthodontics and the Pitts21 team for promoting and for sponsoring this webinar. So thank you guys. It's great to work with OC Orthodontics. We are recording this session and it will be available through both DIBS AI as well as your OC Orthodontics rep and company in the next couple of days. Let's move right into our topic. Our topic today will be presented by Dr. Brandon Martin from Alexander and Martin Orthodontics. His practice consists of multiple locations just north of Sacramento, California. Brandon is both a DIBS AI power user, doing next level work, as well as a Pitts21 doctor. So we're pleased that he is willing to join us and to lend his expertise and talents and to teach us how he is customizing his stock bracket prescriptions. So as Brandon presents today, you are welcome to use the QA function on this meeting. Ask any questions you like. I'll do my best to interrupt Brandon as we go. If the questions come in on time and pick the right time to pose your questions. If the moment's passed and I missed the opportunity, we will revisit any I missed near the end of our webinar today. So I think that's it. With that poorly done introduction, I will turn the time over to you, Dr. Martin, and perhaps you can fill in any gaps in your experience and your practice that you feel necessary as you get started. Does that sound okay?
Sounds great.
Okay,
Yeah,
awesome.
sounds perfect. Ryan, can you enable screen sharing?
Absolutely.
Let's see. Okay.
There you go.
Still don't show that I can share my screen. Let's see.
Well,
I don't know why, but on my side, I was able to switch it to multiple. Did that make a difference, Dr. Martin?
Yeah, so I have audio. It doesn't look like I'm able to turn on my camera or share screen from what I can see on my end.
So if you click that little icon that says share, does it say you can't do it?
Yeah, I do not have the icon. Sorry.
You have other icons there though.
Yeah, chat, raise hand, question and answer, show captions.
Is that on your side, Caden?
I do not have that option. Let me see if I can make any changes.
Okay, I just switched the setting back to balance at a time.
Yeah, I am good to go now.
Okay.
Thanks, Ryan.
Yep.
All right, do you guys see my screen now?
Yes, we do.
Excellent. Okay. Perfect. Well, thank you for the introduction, Ryan. Yeah, excited to talk about this today. And I'm going to kind of talk about my journey and how I ended up where I am now. I was not always a Pitts user. I'm a fairly recent Pitts adoptee, and it's been excellent. But I want to talk a little bit about how I ended up using DIBS AI and how DIBS AI eventually led me to Pitts21, and just a little bit about the awesome synergy I think that exists between these two products. They're just stellar companies, stellar people that are doing absolutely awesome things. Before I get started, though, just a quick introduction. this right here, this is a picture of my family. And these four awesome young ladies are why I do everything that I do. And they are just amazing. And I love going home every evening to them. I love getting up in the morning and the time we get to spend together. And as awesome as being an orthodontist is, and it really is the best kept secret ever, my role as a father, that is first and foremost. And as Ryan said, I'm here in Northern California, just outside of Sacramento, heading up towards Tahoe. It's a beautiful area. I finished up school in 2008. So I've been out for 17 years now. And I did corporate for 2 years, and then I bought my first practice. And this is the team that came with my first practice. I super hate that photo, but I love the people in that picture. So it was a small team, 2 assistants in the back. We had our front office manager / scheduling coordinator in the front, and our TC / financial coordinator. But over the years, things changed. And this is our current team. So we currently have around 25 employees. We're a 3-doctor practice with 3 different locations. And this kind of change did not happen overnight. Thank goodness. It was gradual, it was slow. And while sometimes I look back and I miss the days that it was just a 4-person team, it's been an awesome journey. And as I look back on the journey, I'm like, how did this happen? And one thing that I like to reflect on is what they call the Japanese concept of Kaizen. And it's made up of these 2 Japanese characters. The first character, Kai, that represents trying to find what is good and continually looking at what you're doing good and figure out how you can do it better. And then the second character, Zen, is change. And what the symbol means, what the philosophy is, that you're constantly looking for ways that you can change for the better, how you can have better workflows, how you can improve your outcomes, how your patients can have a better experience each time you walk in the office, how I can be a better leader. And as I look back at the growth of our office, I think this mentality has been a big part of it. We're not afraid to make changes. I treated 0 Pitts cases before I switched to the Pitts brackets. I did a lot of research and I talked to a lot of people. I learned everything I can. My poor representative, Kamal, he'll tell you I was probably going to lectures for 10 to 12 years before I finally switched. But it was a change, and we jumped in and we took the change, and it's been absolutely awesome. So continual improvement, that's what our office is all about. And kind of when I take a look back at it, I look at the major stakeholders in our office and kind of what I'm hoping for them. And the first stakeholders, who comes first above anyone, are our team. And, back in the day, I was definitely one of those patients first kind of guys. And it's, the patient is always right. Since COVID and since kind of some of the changes that have happened and just reflecting on things, I don't feel that way anymore. My team comes first. And if push comes to shove and it's, a patient and kind of how they're feeling, they're experiencing something, and one of my team members, my team comes first. And just shifting that perspective has made my job so much more rewarding, I feel. But I want a team that feels engaged, that they come to work and they feel that they're part of something bigger than themselves. Next, we're always looking for ways that we can improve our patient experience. We want to make things easy for them. We want them to have fun. We want them to have an awesome smile when they're done that just knocks everyone's socks off. And then the final part of the journey, us as doctors, I like to run efficiently. I like to go into work hard, and accomplish awesome things and more work than I thought I could ever do. I like things that are predictable. I don't like surprises. I don't like all of a sudden seeing a gingival runner on a lower right 1 that I didn't expect. And I like being in a stress-free environment. When things are predictable and things run smoothly, I'm relaxed at work. And that's something that I feel that our team feels, that our patients feel. It just creates a vibe. And those are the things that we're striving for in our office. As we've kind of built on this, and we're going to talk a little bit about mechanics and appliances and kind of the direction that fixed appliances are going, just a little bit of quick history. 100 years ago, Edward Angle, back in 1925, he released the Edgewise appliance. And that was the first appliance that we had control of a tooth in all three planes of space. And it was just groundbreaking. But not only that, Edward Angle, he was a businessman. He had 46 patents in the United States. He introduced the E-arch, the pin in the tube, the ribbon arch, and then before he died, his last great invention that he had was the Edgewise system. And the Edgewise system, it definitely wasn't without its faults, but it took orthodontics to the next level. And for 50 years, the Edgewise system is what we all used. And the Edgewise system required a ton of customization. You had to customize the wire in all three planes of space for every tooth. Every tooth in the mouth had the exact same bracket on it. Next, in the 1970s, Larry Andrews came on the scene. And we're all familiar with the 6 keys of occlusion. And that's just kind of been, we all kind of have the same goal. We want that ABO finish. We want to meet all 6 keys. We want a smile that we can be proud of and that our patients are going to wear with pride for the rest of their lives. We want to show some upper incisors. We want the correct angulation of the front teeth. We all have the same goals, but there's been a few of these pioneers that are taking us to the next step in getting to these goals. Larry Andrews, also an innovator, 9 patents throughout the course of his life. And he brought us the straight wire appliance, thank goodness. So we went from these highly, highly detailed wires that we had from Dr. Angle, where we were basically customizing every single tooth in the mouth, to the straight wire appliance, where the idea was we could get the right bracket in the right spot with the right prescription, and you could put in a straight wire and you'd get the result we were all looking for. And, there's always controversy when these things come out. Right now, customized orthodontic appliances, that's the latest rage. We've been using customized aligner systems for 2 decades now, but there's a little bit of pushback about the customized bracket systems. And I found this online. I really liked it. This controversy has always existed. We have the straight wire appliance with, Larry Andrews, pop a wire, put the bracket on, put a straight memory wire in there, have the patient come back, the teeth will all be straight. I'm sure that people were saying the sky was falling and that general dentists were going to take over the orthodontic industry, and all of these things, but none of it came to fruition. But we graduated on from the Edgewise appliance. And now we're to the 2020s. So we're 100 years since the Edgewise appliance, and we are 50 years past straight wire. Now we have scanning, we have cone beam CTs, we have CAD/CAM technology, 3D printing, and custom braces are just now coming on the market. Right now, the fully customized systems that are out there, we have ceramic systems, and then we have systems made out of composite. Unfortunately, we don't have a metal system yet, and that does kind of play a little bit into my journey. But kind of what is my dream? Like, what do I dream about when I go to bed at night? Basically, I would love to have Larry Andrews' original goal of being able to finish every case in a straight wire become a reality. That is my panacea. And why? Why do I want to be able to finish beautiful, just knock your socks off cases in a straight wire? First of all, it would lead to just an awesome team experience. Team members, at least in our office, and a lot of the doctors that I talk to, I don't have the highly skilled workhorses that I used to have. They're not the type that can bend an omega loop for me and put in a lace back and just do all of the things that was traditionally required. They can take wires out, put wires in. A highly detailed wire, that's a challenge for them. Appreciative patients. Patients like predictability. They like cases that finish on time. They like not having to come into the office more than they need to. And then they like results that are just going to blow their socks off. And finally, When I'm dealing with straight wires and not repositioning half the brackets in the mouth and adding 30 degrees of torque to a wire, I'm much more relaxed. I get to spend time with my patients. We get to make small talk, and that's the best part of what I do. So that's kind of what we've been striving for over the last couple of years in our office. And just a little bit about my personal journey. When I first started down this, the first thought that kind of jumped to my mind is, man, I just must suck at bracket placement. And hand placing brackets, it's time intensive. If you're running a busy office, it's something you can't delegate. You know, you'll have somebody waiting for you to pull you into a console. There's a pan repo you need to look at. Maybe there's an expander delivery that could be going a little bit better in chair two with some tiers, and you have some brackets sitting on that are ready for you to go and position the brackets. And so bracket placement was kind of where we first began our journey. And what really kind of drove it was, I have this goal, this straight wire, but this is what my wires look like. I mean, I have a detail bend on almost every single tooth in the mouth there. So what's going on? And that is what led us down the path of indirect bonding. And in our office, we actually started indirect bonding 10 years ago. And these are handmade that we made here in our lab. This is an old indirect bonding tray, which I dug up. I was surprised we still had one. But these were indirect bonding trays that were made out of hot glue, actually. And they worked surprisingly well. But it was all manual. It was us using our best eyes, our best vision, our best guesses as to where that bracket should go. The hot glue gun came out, the bonding trays were made, the transfer happened, and that's how we put braces on for 10 years in our office. Thank goodness DIBS came along. DIBS is just such a better way at doing this whole process. And this is a little promotional video from DIBS that just kind of shows how you get to see your AI-driven predictive finish right from the beginning. Instead of a hot glue gun tray, it's a tray that's 3D printed. Surprisingly, very similar consistency to the hot glue, though, and with just a super accurate transfer. So we started using DIBS AI in our office about 2.5 years ago. And man, things started to get better. I don't know if everyone on this call's had a chance to really dive into the software, but it is beyond excellent. There's a lot of movement in this space right now. All of the big players are now coming out with their digital indirect bonding programs. Ormco has theirs out. 3M Unitech or Solventum, they have theirs out. There's a lot of competition, but none of them are near the caliber or the accuracy of what DIBS AI does. The amount of predictive technology behind all of this is insane. When we go back here, just some of the things we were looking at in this little clip that I shot. So first, we're choosing our arch wire size. So you're going to choose which wire you finish in. Personally, I finish my Pitts cases right now in a 2020 TMA. And part of that is the amount of customization that I'm building into the case. I do want to fully fill that slot. You specify what the corner radius is. Before I started using DIBS AI, I had no idea what the corner radius of an arch wire was. We'll talk a little bit more about that as well. You're able to visualize your marginal ridges, rotational correction, and then you're able to simulate where your predictive finish is going to be. So this is a typical Pitts21 case that I set up using DIBS AI. This is a patient we started about 3 or 4 months ago, and we'll take a couple peeks at this particular patient as I go along. But right here, if you take a look at this, you can see the 2020 arch wire fitting into the Pitts21 slot. You can see that it has formed a couple at that point and that we are expressing torque. And in an ideal world, meaning if that was a perfectly, absolutely rigid stainless steel wire and these teeth were floating in outer space, there was no bone, no resistance, this is exactly what that case would look like. And that's the power of the predictive technology that's driving this system. You can just kind of see how that plays through each bracket as we go along. Now, a lot of Pitts users, and so here's the case. She came in November, right before Thanksgiving, and sitting in our chair, and we see a bit of an open bite, slight little class 3 tendency, little bit of a Bolton discrepancy, but overall not a super difficult case. There's some kind of end-on cross bites over here on the right hand side. But the big thing that jumps out at me, and I'm sure all of you very seasoned Pitts users, is that she can't show her teeth when she smiles. We're looking at about 25% incisor display on full smile. And these are the cases that I've become very, very excited about over the past year or two. And so when it comes time to set up this case, there's a lot of different ways to do it, but with DIBS AI, it gives us just a ton of different tools. And in this one, when it comes time to customize it, so this is the setup that I actually approved, but you can go here and click on this box, treatment options, and it has all these built-in options. And here you can see just a whole line of different bracket placement protocols. Pitts here at the beginning, Damon, MBT, Roth, Alexander. And so let's play around with that for a little bit. So here's our patient. Let's go ahead and see what this looks like if we plug in the average MBT bracket placement. So here it's going to change it. That's just a little cringy. You can see how that just standardized placement has really just super flattened her smile arc. So here I switch it to a Roth placement, and that's with the incisor brackets at 4 millimeters. And now we've got a reverse smile line. And here is a Pitts SAP++ bracket placement. And there you get to see your pre-treatment visualization of kind of what's possible with the smile arc with this case. And it's just kind of the real-time predictive treatment planning that has just opened up a whole new world for me. Good. So moving along. And here I just did some screenshots that I overlaid that kind of shows you how big of a difference the placement of the bracket on the tooth makes. So here's our pre-treatment. Here is a Roth setup if we put the central incisor at 1 millimeter. Here's an MBT setup with it at 5 millimeters. This is a Pitts SAP setup. It's 6.5 millimeters, starting to look a lot better. There is a 7 millimeter, the SAP Plus. And here is a SAP that has this case at 7.5 millimeters. Now, I hear a lot of discussion about the vertical height of the bracket and how those measurements are calculated within DIBS. And DIBS actually does give you a lot of freedom in how you want them to run these measurements. There's 3 different ways that they can do it. This slide, they are running the measurement off of just looking straight head on at the bracket at the pre-treatment angulation of the tooth. This one, the measurement is measured by the post-treatment measurement. If you look, it's just the flow is much, much better when we use the Pitts norms with the predicted tooth position. And then finally, they give you the option to measure the bracket height perpendicular to the base of the bracket. That is the 3rd way that it can give you your bracket measurements. And you can see when you do this one, that's more of an 8 millimeter, 8.5 millimeter, even though it's set to 7.5 millimeters. And what that is, it's all just changing the angulation of the tooth when it's running the measurement. And you get to pick which measurement's going to work best for you. So what is this? Like all of these different cases are measuring at 7.5 millimeters, but the bracket's clearly in different places with each when you change that setting. And it's something called a parallax error. And what a parallax error is, it's errors that are made when you're measuring the heights of things that are slanted. So if you try to measure something that's slanted, depending on what perspective you're looking at it from, you can get completely different measurements. Steve, who is the founder of DIBS AI and OrthoSelect, he likes to use the analogy of the Leaning Tower of Pisa. If it were standing straight up, it would be 196 feet tall, but it's tipped over 4 degrees, just 4 degrees, but that makes it 183 feet tall. So this is why some of the measurements when you're using DIBS will look different than what you're used to. And so what I would recommend is diving into the software a little bit and kind of seeing which of those measurements is going to work best for you and your style. So here we see the first option, which is having the height of the bracket measured according to the pre-treatment angulation of the tooth. The second option is to have it measured to the predicted angulation of the tooth. And then the third option is if you put the base of the bracket straight up and down, measuring from the incisal edge to the slot on the bracket. So all measurements in this case, they're all 7.5 millimeters measured from the incisal edge of the tooth to the slot of the bracket. But the bracket, as you upright the tooth, it goes further gingival and gingival. And this is that parallax effect that I was talking about. Personally, what I do is I use the predicted, and that is the default in the DIBS AI software. And I find that it's the most reliable and provides the best flow that I like to see in a smile when I'm done. And just even if you are just using the presets, remember this is all customizable. Every case when I'm setting it up, I have the smiling photos on one screen, I have my DIBS on the other screen, and I'm customizing that case for that patient's smile. Good. And so here we have our height gauges. Clinically, when we're doing the height gauge, we're just as susceptible to this parallax error as we are when you're looking at it through the software. However you angle your gauge will change where that bracket is positioned on the tooth. Most of us, I think we're trying to aim for it just directly kind of perpendicular head on to the tooth. Good. And then the other question that I'll often hear about when setting up cases is just how far gingival can you go? And you can go pretty darn gingival. Just a couple of things that I do when I'm going for really gingival placement in my cases. I do feel comfortable tucking those brackets under the gum, 1/4 of a millimeter to maybe 1/2 millimeter. And here you can see how I've turned the perspective onto the inside. And when you flip it around to the inside where that view was, you can actually see how much of that bracket is tucked under the gum. And kind of, is this reasonable where we're at there, or have we gone a little too far? And right where we're at right now, that's about as far as I'm comfortable going, as far as tucking a bracket underneath the gum. And so there is really quite a bit of flexibility there. I feel that you can go almost as you can maybe go another 1/2 millimeter subgingival clinically that you're not able to go predictably with DIBS AI, but it's been a great option. Good. So first of all, that's what I tackled. I tackle my bracket placement. I'm like, okay, I'm going to get the best technology out there, and I'm going to have the most accurately placed brackets that I possibly can. But what was I finding? Man, I was still bending and detailing way too much. And I thought, okay, well, I need to start customizing these setups. The DIBS AI software is super powerful. None of the other programs out there let you do these things, but you can take a stock bracket, and the base of that bracket does not need to be flush up against the tooth. You hold the shift key as you're changing the torque, as you're changing the rotation, and you can completely customize the base of the bracket and wedge it to get whatever prescription you feel is best for that particular case. Custom is just always better. You can go buy a suit off the rack, or you can have one tailor fit for you. You can go to Home Depot, you can buy a shed, or you can hire someone to come out and they can customize a shed any way that you want. You can go to Disneyland, you can pay standard admission tickets, which is the only thing I've ever done. Or if you want a truly customized experience, you can go on a VIP tour. You can hire your own plaid that will skip all the lines and just give you an experience like you've never had before. It only costs, I think last time I checked, it was $600 to $800 an hour with a 7-hour minimum. So, you know, it's about a $5,000 experience, but you can have a custom experience at Disneyland. And with our bracket setups, same thing. We can completely, using DIBS AI software, customize our setups. So out of the two different, the traditional stock system that's available or customized setups, There are some big differences. First of all, placement. When you're hand placing a case, and like I said, in the busy clinical day, it's very time intensive and it's stressful. Custom brackets, very minimal doctor time. We go through our start cases in the morning where they pull up the DIBS, we pull up the treatment plan. I tell them where our bite protection is going to go, what type of bite protection to use. We go over elastics that we're going to run, everything. When the case is done, I'm checking the quality of the transfer, checking for any flash that they may have. And I'm basically just doing a meet and greet. My doctor time is 2 or 3 minutes for a start, unless I feel like taking more time just to connect with patients. Cost, stock brackets are cheap. And so they're widely available. You can keep, extensive inventory. Custom brackets are expensive. Workflow. Stock brackets, it's a really simple workflow. You order them, you store them, and you pull them out as you need them. Custom brackets do involve digital homework. And so it's more complex and it does take more time on the front end. And then materials. Stock brackets right now, the best material out there to make a bracket out of, definitely, hands down, I feel is stainless steel. And so that's what most of us are using for the majority of our cases. Custom braces right now are only available in ceramic or resin. We don't have the technology yet to custom print a truly custom metal bracket, but I can see the day where that would come. So right now, what do we have? We can do a semi-custom approach where we're customizing the base and, out of the things which we would want, which is minimal doctor time, we're getting that minimal doctor at the chair time. Cheap. DIBS AI is the best bang for your buck out there. I mean, it is absolutely amazing. $165 a case for a customized setup. Doesn't get any better than that. The workflow, there's more digital homework. Okay, so to truly set up a case the way that I feel that it should be set up, it takes me 10 to 15 minutes a case. But that 10 to 15 minutes that I'm spending on the front end is saving us so much time in the clinic and dollars on the back end. And then finally, you get to use your favorite bracket. I get to use my Pitts bracket and completely customize it using materials that are just super awesome. So what do we want to customize? We want to customize everything. And here's I'm just going to go through some scenarios of things that I'm routinely customizing. First of all, so this one shows a crown that really doesn't even look like a tooth. So you can see the size of the wedge that I have on the base. There, I connected the bracket to the tooth again. So if I just glued a bracket on this tooth, that is what the prescription is going to do. Here we can see the wedge that I've created that is bringing the tooth into proper alignment. And so that is how I will wedge the base of a tooth to get a more customized setup. And you're like, man, that is a lot of glue. How is that going to stay on the tooth? We've been doing these customized wedges with our brackets for about 1.5 years now and have not noticed any noticeable change in our debond rate. So here we see what I have set up in the DIBS setup. And then we use adhesives that fluoresce so that we can see any flash, see the quality of our transfer really easily. And here you can see what that wedge looks like on that crown in the patient's mouth. Other things we customize, just abnormal tooth shape. You get some teeth sometimes that are just really flat. You get a molar that's really straight up and down like this one. And so what we do is we've wedged the base there. And when we take a peek at what it looks like clinically, here's the wedge and in the predicted setup, and this is what it looked like on transfer day. Extra cusps, you see some weird things. So what do we do in a case like this? Well, in this case, I just put a bracket on it and we can see our predictive setup, how it's going to kind of line up in the position that I have it. I can customize the torque. I can customize the tip however I want. And then we go into the clinic and we transfer it. So this last second molar here, this upper left 7, there we can see the custom bracket base on that and it works. Now that's a really big talon cusp. And it was kind of funny. I was looking at this. I'm like, I didn't really put a bracket on that, did I? But I went and looked and yeah, I sure enough did. And just the way that I was able to change the torque on that in the here's the simulated setup. I'm still able to get a nice flow through those buccal and palatal cusps, even though we have a huge talon cusp on that one. This one is huge, and I don't think I appreciated quite the underlying problem here until I started using DIBS AI. But we get those lower sixes that have a very large distal lingual cusp. And so we have the lower sixes that have 5 prominent cusps. And what happens is if you put that bracket just right in the central groove where it should be, and you don't customize it, very typically, it is going to put a force on that tooth that's going to want to roll it in lingual. But what really happens is that's a big molar with some big roots, is it kicks your lower 7 out buccal. And you end up with lower 7s that are in crossbite. And for years, I've been seeing these lower 7s that end up in crossbite, and none of it made sense to me. It does now. So you either have to take that bracket and you have to cheat it to the distal significantly so that you don't rotate that molar, or you have to wedge the base. I would say lower 6s, I have to do this sort of customization on at least 60% of the cases, so that we end up with it with basically without having cross bites of the posterior 7s and the type of flow we're looking for.
Hey, Brandon.
Yes.
Yeah, before you move off that topic, just a quick questions come through. I thought it'd be a time to interrupt you there. Sorry.
Yeah.
Just when you're looking at these cases in the software, how do you know you need to put a custom base? That question kind of came in a little bit after you showed that original torque. Is there something in the software that's showing you, or how do you identify that you're going to put a custom wedge to produce or take away torque?
Very good. For anterior teeth, I'm going back to what my treatment goals are. If I have someone that's a bit bimax and I'm really trying to upright incisors, there's a good chance that I'm going to, there's a lot of options out there. Some systems market variable torque brackets where you're stocking 3 or 4 different torque prescriptions where you alter that. There's always the flipping of a bracket, with the Pitts system, you're changing your torque by 24 degrees when you flip a bracket. Rather than any of those options, I choose to wedge the base. And so if somebody has a flared incisors, I'm going to put a 15 to 20 degree wedge in the base to upright those incisors. And so that is mainly driven by what the predictive outcome looks like and what I want the predictive outcome to be.
Do you slip? I'm going to cheat a little bit because I know there's one way to visualize that. You're looking at the predicted outcome. Do you put the wire in to see where there's potential wire bends?
In DIBS, you can adjust your settings so that it does not reflect wire bends, and it just shows the true expressed torque in the system. And that is what I look at, is the expressed predicted torque, and if that's meeting my treatment goals or not.
Okay, excellent.
Hey, Brandon.
Yeah.
To the question, that's a perfect example of what you have on the screen now. In the predicted outcome, you're going to see that marginal ridge is off. So you literally just held down your shift key, clicked the rotate button, and created that wedge. So
Absolutely.
it depends what it is. In this case, it's a rotation. In the case of torque, you're going to see those cusp tips. They're just out of alignment. They don't, the buccal lingual don't line up. Again, you hold the shift key and you bring, let's say it's a lingual cusp tip that's sticking really high. You're just literally bringing that tooth down, and it automatically creates that gap to where you want it. Same with tip or anything else. So anyway, that was my 2 cents on that.
Yeah, absolutely. So yeah, anterior teeth, that's basically how I look at it. And Steve, just like you said, for posterior teeth, I kind of take the occlusal plane and I tip it up a little bit so that I can just see how those palatal cusps are flowing. And every once in a while, you'll have like a second premolar or first molar where the flow of those cusps is just off. And so there I will go in and I will customize that torque so that it flows well with the rest of the teeth. With the Pitts system, there are a few things you need to be very careful of. So pre-adjusted appliances, that's what Larry Andrews created. The Pitts bracket system, it's not only pre-adjusted for an ideal outcome, but it is pre-activated. And the pre-adjusted versus pre-activated, it's an interesting concept. And if you look at the amount of torque that is built into those upper first and second molars, it's quite a bit. It's a lot of buckle root torque. And it's more than we would ever want to see clinically, but we're not going to see that clinically. And so you don't want to go in and take out that pre-activation. You want to keep that overcorrection that's built into this system. And but I do smooth out the big discrepancies and things that just don't look right. Does that answer the question?
Yep. I love it. Thank you, Brandon.
Cool. Yeah, and then this next
And
slide just kind of shows the flared
Brandon,
teeth.
we have some other questions, but I think you're going to go over some clinical things in a minute, right?
Yeah, I'm going to pick up the speed a little bit so we don't run out of time.
Okay, I'll wait for the clinical questions when we're there.
You got it. So here's somebody with some flared teeth. And just like we were discussing, you can see how I have uprighted those teeth. And when I'm setting up a case, I'm looking at the predicted outcome. That's all I'm really looking at. And you can see the degree of wedge that I have there. I haven't calculated what that wedge is, but it's probably a good 12, 15 degree wedge to get the uprighting that I want to see in this case. That's what it would look like without a wedge. And then that is how upright it is with the wedge. So instead of flipping the bracket, I'm putting the torque, customizing the torque with the base. And part of the reason is, man, this makes life easier for my team. You know, we don't have to be looking at the chart to figure out, okay, which brackets, you know, did we flip? Did we not? You know, are we checking to see if it's been overactivated and we need to switch it back? It just simplifies our workflow a ton. Good. Here we just see some variation in two shapes. So all of these are lower second premolars. And if you look at that facial surface where that bracket's supposed to go, I mean, they're all over the place. This one's pretty much straight up and down. We have about a 30-degree angle here, and then we have a 45-degree angle over here on the side. So these are some of the customizations that I'll do at the base. But then the thing is, man, you know, we're doing all this work customizing it. Does it actually transfer? And this is just a case that actually we strapped up yesterday. And after I had them scan it after they did the transfer. And I just went into Mesh Mixer and I superimposed the DIBS STL with the STL from what it looked like immediately post-transfer. And I'm just blown away by the accuracy of these transfers. The hot glue gun, you know, I always felt that my transfers were off by like 0.5 millimeter or anything like that. The DIBS AI transfers are beautiful. When we transfer and I like go back and I look at a tooth and I'm like, that just doesn't look right. I pull up the DIBS AI and every single time, darn it, that's exactly where I put it. And then the last part of my journey. So I was going all in on things. You know, I'm customizing my setups. I'm spending a lot of time on them trying to get the results I want, but I still wasn't seeing it clinically. And I was just scratching my head. And I was at a meeting where they were trying to promote a new bracket, and there was just a slow adaptation rate. And it was the craziest marketing that I'd ever seen. But basically, they took their previous generation bracket and just convinced everybody in the room how horrible that bracket was. And that bracket was the bracket I'd been using the last 10 years. So I went back and, you know, I walked out of there. I'm like, I don't know what I need to do, but I need to take a close look at my brackets and I probably need to switch brackets. And so I got home and I realized, yeah, the system I was using had an incredible amount of slop. And what slop play is how far you can rotate that wire. You know, how much rotational freedom do we have until it actually engages the bracket and produces some torque? Okay. And it's really interesting. A lot of companies talk about their engagement angles or, you know, how much slop they have in the system. And I basically didn't really believe any of them. So I went and I made myself my own little jig where I could measure how much slop play we had with all the different systems. I went and got all the passive systems out there and I built my own jig and I tested them and I figured out exactly how much slop each of the systems had. And darn it, the system I was using had a ton of play. And I knew it did. I mean, I knew that if I wanted to get some torque on an upper right two, I had to put 30 degrees in the wire if I wanted to see 10. So I knew this, but I didn't realize how detrimental that was. So the bracket I was using when I did my own testing, 18 degrees of play is what I got. The tightest tolerances I found, and there was one that I found that had tighter tolerances than the Pitts21 bracket. It only had 10 degrees of play, but they called them sharp wires and rounded wires. And they did not recommend that you use the sharp wires at all because they were just too hard to engage. And they recommended you use these round wires. When you pop the round wire in there, it was almost 20 degrees of play. So the sharp wire is really the only wire that worked. But they don't recommend you use it. So that one turned out being a no-go for us. And we landed on the Pitts21 Pro. And man, what a game changer that bracket has been. And we adopted that November of last year. So we're about 15 months into the journey, and it has just been phenomenal. When I was looking into this deeper, I did find a study, and I mean, we've known this for a long time. So this is a study that came out 10 years ago. And here we see a lot of the popular systems that are out on the market. And I was using the second generation of this top one here, but 24 degrees of play. I mean, even if you're using an MBT prescription or something with 17 degrees of activation, there's 24 degrees of play forward and backwards before it engages. That's just incredible. Kind of like this little conclusion one of the studies had. Slot heights are constantly oversized. Arch wires are slightly undersized. Edge bevels, an unavoidable consequence of making a rectangular arch wire, are extremely variable from one product to another. The torsional play is usually significant and can nullify most of the common use prescriptions. And that was what I was experiencing in my office. And so here's a little bit about that slot play. So here they just went and they got a bunch of wires, and this is what a wire looks like if you run a cross section on it. They're not square. They have these rounded corners, and you do need to know what the rotational bevel is on the wires that you're using, and you input that into DIBS so that it's giving you an accurate predicted outcome. What are some of the other systems out there doing these days? They're intentionally rounding the wires. Shape makes the process smoother than ever. It makes it smooth because it's no longer doing its job. And that's what I appreciated most about the Pitt system is they're doing everything they can to engage three-dimensional tooth movement as early as you can and as effectively as you can. And it's just been awesome seeing the results of that. These little channels they put down here, so you can't cast a metal injected molded bracket and have a true 90-degree corner. And so they put these two little channels here so the wire can engage without getting caught on a rounded corner. I mean, the engineers over with Pitts21 are awesome. I've had a chance to talk to them, to pick their brains about things that didn't make sense to me. And they have been in this industry for a long time, and they have a ton of experience. And they're leaning on the experience of Tom. They're leaning on the experience of Duncan Brown, all the other pioneers that have figured this stuff out for us. Other things I like about the Pitt system, when I think Pitts, I do think precise. Their stuff, it's made here in the US. These are their manufacturing facilities in Oregon. This is the manufacturing floor where it all happens. We don't have to worry about tariffs. We don't have to worry about shipping out of foreign country issues, none of that. It's all here locally made, and they hold the bar high. This metal injection molding process, it's not easy. Take metal powder, mix it with binder, get feedstock, stick it in an injection, then you put it in a kiln, and eventually, I mean, there's so much room for error. And what I found is these molds, they're very expensive and they wear out. Most places are not replacing their molds very often, and their brackets are not reliably consistent. But that has not been my experience with the Pitts Pro team. And then just to summarize here before we go back to questions, I'm just blown away by what we're able to see. So here's a patient that came into our office. She had records taken February of last year, so about a year ago. She didn't get started for another 2 months after that. She had been in treatment with a general dentist using removable appliances, and these big globs you see on the lower sixes are bite turbos they were trying to disarticulate her with. trying to fix this crossbite. And I guess they'd been working on it for 3 years. So this patient came in. I don't remember how they found our office, but just super awesome girl. We strapped her up in April. Came in, we changed wires, went to the 18 square wire in May. Stayed in the 18 square, and we got that lateral incisor fully engaged in July. And then here we are at her third visit. So at this visit, we're heading into the 2020 NiTi wires and going to let those cook for a little while. You can see crossbites have been resolved, smile arc, just everything's coming along, looking a lot better. And then here she is in November. This was our progress panel. I'm sorry, this was in January. So we took our progress panel on her. She's 6 or 7 months into treatment. And I remember looking at this case, and kind of just looking at the shape of the arch, kind of just the symmetry that's kind of been brought back. I'm like, this could be a done case. You know, it does not need to be a done case. It's a case that I still have 5-6 months on to make it even more awesome. But it's just mind-blowing to me that I'm able to do these things in 7 or 8 months and be in final wires and starting to work on the detailing and what makes a case just absolutely spectacular. And then just one final case. This was one that we just started, and this is one we were looking at earlier, that open bite case. So she came in right before Thanksgiving. This is when we played around with the bracket placement a bit. And I remember the day that we put her braces on. Oops, sorry. You could not see her braces on the upper arch. They were like fully under her lip. And I'm like, well, yeah, I guess this is what the SAP placement's all about. She came back for her second visit. I couldn't believe it. She smiled and I'm like, no way. Those are her braces. There's just no way. Open bite fully resolved. Just the incisor display and that smile arc just already heading the direction that we want it to go. And it's just an awesome system. Kind of in summary, these are just two excellent companies, and I love the direction they're going. DIBS, we have their predictive AI-driven treatment planning. You can customize any stock bracket. It's affordable, and they're getting better every day. Pitts, it's precise. It's a true 4-wire system. You're getting 3D control early on, and they're getting better every day. I've heard a lot of the consultants say, you know, that the Damon Ultima might be the last mass-produced non-customized bracket ever. I don't believe that. I think Pitts is going to continue innovating. They're going to be bringing new products onto market. I do think they might be one of the only ones. And then eventually things might go custom. But I just love partnering with companies that have that same desire to get a bit better every day, just like I do. And that's what I had to share. Should we head to get questions, Ryan?
Yeah. No, thank you, Brandon. That's awesome. Okay, I've got a little bit of a list here for you of questions. They tend to be more clinical and operational, believe it or not. So let's see. How do you communicate to your team that there will need to be extra composite or wedge on the base and on which teeth?
Good question. Let me just flip forward a little bit here. I've got a couple of slides that address that. Did my screen share go away?
I did. Yep, I lost you.
All right. Good.
There you
All
go.
right.
You're back.
We're back. Perfect. Yep. Okay. So this just shows a little bit about how our team sets these up. The first thing that they do is they put some primer into the pad of the bracket. They go and they lightly air dry the primer. And next they come, and we're using Go-To right now, but they butter in some Go-To. And the way that they know how to fill them, and so here they butter it in and they use a micro brush with a little bit on there. But do you see this slide right here? If you look close, you can see the surface of the tooth and how big the wedge is before you get to the pad of the bracket. So this one right, does my mouse show on this, Ryan?
It does. Yep.
Yeah. So right here, you can see that the
bracket,
adhesive,
your bracket on top too might be a good way to visualize that gap.
yeah. Yeah. Um, yeah, so right here you can see that the adhesive is flush with the edge of the DIBS tray. Here you can see one that's not filled, but you can see that it's going to need to be filled to this line right here where it becomes flush. And so just kind of by looking at and kind of learning how to read the DIBS tray, they can tell how much adhesive to use. And it's a skill that they pick up pretty quick overall. Been pretty impressed with that.
Okay, excellent. That actually answers the other question I had, which was, do your assistants go over each case in the software beforehand so they know if they need to place extra adhesive? And it looks like they discover it basically as they're putting the adhesive on, is what you're saying.
That is correct. And so when we first started, we instructed them to open up the software, go through it tooth by tooth, and see which ones had noticeable wedges. That's too time consuming. You can tell just by looking at the trays.
Okay, excellent. In your bonding procedure, do you push on the facial of the tray, and does that create excess flash? I mean, if you have a glob of, I'm gonna riff a little bit on the question, but you have a glob of adhesive there, and if you push on the facial side, does it spread out that adhesive and create flash?
Good question. It's very similar to Invisalign attachments, I feel. You know, a seasoned, well-trained assistant, they know how to fill a transfer tray to get it kind of just right so you're not going to have a ton of flash, but you know, also not be stingy and have any voids anywhere. It is something that just takes a little bit of practice. In our office, we have actually have one person in each designated office that fills all of the Invisalign transfer trays and the DIBS transfer trays. This way, we're able to give them feedback if they're overfilling or underfilling and just really dial in those key players. And the goal is, you know, basically perfection is what we're going for, but just a slight puff, but nothing excessive. And we've been quite successful with it. They do not feel that it's any harder to predict a DIBS tray than it is an Invisalign tray.
Okay, excellent, excellent. When you add a when you add that much to a torque wedge, what happens when you have to rebond? Can you get a rebond tray, or how do you handle that scenario?
Good. Yeah. And you know, so customized systems all have transfer trays. Anything that is customized, the only way to get it from how you worked it up to what it's going to look like is by making a tray. Um, Interesting thing is, you know, you can print repair jigs if you want. This is not something we've been routinely doing in our office, but it is something we've thought about. But you can go into the DIBS software and 3D print, you know, individual repair jigs, which could then be used to place the bracket. The advantage here is you could do all of your repairs on non-doctor days, kind of since that's already all been decided. The positioning of the bracket has already been decided by the doctor. So we're looking at this, but we haven't embraced it yet.
Okay,
So if we do have a broken bracket, we hand place it and we lose our customization.
okay. You mentioned going the ability to go subgingival with DIBS AI. Have you ever had to do a custom base subgingivally?
Yes. Especially upper anterior, like the trouble tooth is always the upper lateral. You know, and a lot of those upper laterals are slightly undersized, but not enough that the patient's going to want to go through any bonding or anything like that, unfortunately. And so you've got to get it as gingival as you can. And the software sometimes will start to misrepresent kind of the anatomy of the root as you go subgingival. And what I found is if you hold that shift key and you customize the base a little bit, then it will stop trying to adapt to what it's predicting the subgingival anatomy to be, and you can go subgingival much more predictably. Most of the wedging, though, it seems, is wedged so that the contact point is at the subgingival point, and the wider part of the wedge is at the incisal point. And so I think that helps as well.
Excellent, excellent. One more question is, unless some more questions pop in here, but the last question, Brandon, is what would you say is actually the biggest clinical challenge of doing this? The biggest challenge you've had with staff and getting them to do it correctly?
It's a good question. It's been remarkably smooth. I think we had a smoother transition than most because we'd already been indirect bonding for so long. And so just switching from a tray made out of hot glue to a 3D printed rubber tray, it just was not that big of a transition for us. Our team, they love indirect bonding. Um, they they like the empowerment that it gives them. They like that they're doing something that they feel is meaningful and that they're delivering care. So it's really just kind of been a net positive for us. New hires that we have that we onboard, they pick it up surprisingly well, and it may just be that we do have some veterans that can just train on high levels. I don't know. We have two that are new RDAs in our office, and they both just started doing transfers probably a month ago, and they've just got it down. So it's been a smooth process for us.
Excellent, excellent. A couple more questions have come in. Um, what is the learning curve to learn the DIBS software program, and how much time do you spend on a DIBS setup per clinical day?
Good. The software I feel is excellent. I have played around with all the other indirect bonding softwares that are available on the market. It is extremely powerful. 2/3 of the features that it has, I never use. As I've kind of got my flow down as I set up a case now, but it still takes me on average 12 to 15 minutes to set up a case the way that I want it. Sometimes I start going down little rabbit holes where I'm fine tuning my treatment plan. We do case share, so they're very specific treatment plans on what I want for a particular case. But I also truly feel that the time and energy that I put in properly setting up a case is going to yield dividends down the road.
Excellent, excellent. Okay, let's see. What is the typical turnaround time of a case from scan to bond?
Awesome. We book 2 weeks out. Ryan and Steve, you know better than I what the actual turnaround time is capable of, but the 2 weeks is plenty of buffer that we never need to worry about it. So yeah, how fast can you flip them? I don't know.
It all depends on how quickly the doctor approves the case. If
Yeah,
they,
Yeah.
so
we typically get a setup back to you within 24 hours. As soon as you approve it, we're printing and shipping within 24 to 48 hours. So it can be quite quick.
Yeah, we book 4 weeks for aligners and 2 weeks for our fixed appliance setups. And if they ever have to reschedule people, it's our aligner people. It's never the brace people.
excellent. Okay, I got a long question for you. So buckle up here, Brandon. A rotational wedge essentially adds depth to the base of the bracket. That would create an offset relative to the other brackets. Do you find that multiple brackets will need an offset base to compensate for the wedge?
So I do see this, and where this most frequently comes to play are those lower sixes. And so as you do wedge it, it does push that tooth more lingual. And so you kind of just have to find the happy spot, and I don't compensate the adjacent teeth significantly to make up for it. It is interesting. I mean, the software will let you just take a bracket and hang it off the tooth a millimeter. Basically putting a palatal step bend into the system. I don't do that. I do always have some metal touching the tooth. And so there are cases where, being a semi-custom setup, it's not as ideal as I would want it to be, but I do like knowing the compromises I'm making from the beginning.
Excellent. His second question here is, will the system recognize this? And the answer is no. The system doesn't recognize that. Okay, let's see. What is maybe Brandon, you understand this. How efficient is the setup for OGS cases? Is it just like setting up a regular braces case? What's an OGS? I'm not sure what that is.
Is that a pano maybe? Different term for a Panorex X-ray?
That's a great question. I don't know.
Anyone else have a way? if that's what they're referring to, I do have the, so what I'm,
Here we go. Orthodontic surgery case.
oh, a surgical case. Yeah. Yeah. So surgical cases, basically I just want to build in, usually surgical cases, there's a ton of decompensation that is needed. So if you have a class 3, I'm going to be uprighting those upper incisors a ton, especially if you're not extracting in the surgical case. And so, those are ones where I'm just overbuilding the decompensation that needs to happen. And so once again, just what is my goal for the tooth movement I want to see, and I'm using the predicted setup to get it there.
Okay, excellent. Excellent. Let's see. I'm just going through these questions. I think we've got most of them. The last one I'll probably take. Brandon, I'm going to take your screen away from you. If I can. Let's see. Can I stop your, or if you'll shut it off and let me take the share option, if that's all right. Thank you. Thank you. Thank you. I'm just going to share my screen here as we end. If you're interested in more details, a couple of the questions were very specific to DIBS AI pricing, things like that. So maybe the best is to offer this. If you want to scan that QR code, you can schedule a personal presentation there around your schedule, and that makes sense for you. Oh, well, actually, one more question before we end, Brandon. This is for you. User says they've used Light Force and they get a ton of broken brackets. And do you get similar issues with DIBS?
One of the big issues when I talk to, my buddies using Light Force, the ceramic brackets themselves, at times fracturing, and just the quality of metal brackets, that is not an issue. As far as debonding, so bond failure, our bond failure rate, is excellent. So we're doing really well there. And the only cases that we hand place are phase 1 cases. And we have no difference in our bond failure rate between the hand-placed phase 1s or our comprehensive cases.
Okay, excellent. Okay, and then another question has popped up too. How do you go about bonding ceramic crowns or including in a SSC into the setup?
Yeah, so ceramic, we just use our ceramic, bonding protocols. Silane, the hydrofluoric acid etch, and it transfers with the DIBS tray just like any other tooth. Stainless steel crowns, man, I hate bands. We only use bands for surgical cases. It's required by the surgeons in our area, and for stainless steel crowns. Other than that, it's all 3D printed bands now. But yeah, so stainless steel crown, skip it in the simulation, put a band on it. That's all I got.
Excellent. Okay, I think we'll draw the line there. While we have a blank slate here for questions. Brandon, thank you. This has been great. We're grateful for Brandon and everybody that's attended today. We ended up our high point, I think, was 151 attendees. So thank you, and special thanks to Dr. Martin for sharing with us today. We will, just a reminder, we'll make this webinar available for review, either on the DIBS AI support website or through your Pitts21 rep. And if you'd like to learn more about DIBS AI, on your screen is a QR code. You can schedule a personal overview of the DIBS AI software, the process, the system, the pricing, all of that is there available for you. And I think that's it, everyone. Thanks again for joining us, and have a wonderful night.